All right.
All right. So the important thing to know for the kind of overall big number performance is that it's built out to have about 400 teraflops of performance, whereas Janus was about 170. But the important thing to know about how to use that is that Summit is heterogeneous, whereas Janus was almost entirely homogeneous. So Janus was a bunch of half-U servers with Intel processors in them. There is a large portion of Summit that is that. A lot of Summit's performance comes from 20, I think, NVIDIA K80 GPUs, as well as upcoming 20 Intel Xeon Phi Knights Landing processors that are 64 core each. And using each of those is a bit more of a special purpose thing than you might be used to on Janus. But we want to enable you to do that, which is why we're spinning up new consulting resources and things like that. But we'll get into a bit more detail about that as we talk. So let's talk about delays. So Summit is installed and is basically working. As you can see today in October, we are doing GPFS scratch storage acceptance testing. So if you use Janus today, that's the Lustre file system, but we're moving to GPFS for Summit, largely to support a more diverse workload as we're expecting more and more types of users on the system. And we do have a certain kind of small set of pre-selected users running tests on the system that are more about validating that the system performs as expected than doing any real work. So don't feel like you're missing out if you aren't on the system yet. The biggest delay in our schedule has simply been the availability of the OmniPath Interconnect. Straight up as a product and since our entire infrastructure was built around not only having it, but being one of the first sites to deploy it at our scale, we were kind of bumped up against that. We've also had a little bit of trouble, and this is why we're still doing GPFS performance testing, getting GPFS to perform as expected on this interface. This is something that's ongoing that we're working with our vendor literally every day right now to try and sort out. But we're making work to be done. How the system works, it is mounted. If you have access to the system, you can see it, but it just doesn't work as fast as we wanted it to. We're hoping for general availability in late November, and unless we hit more delays with GPFS, there's no reason why that won't be the case. Again, it's largely complete except for the file system. But then, as I kind of alluded to earlier, we don't have the Knights Landing portion yet, and we weren't intended to have it yet. It doesn't exist as a product. There are versions of Knights Landing that we could get, but part of the goal is to use the what is variously called the -X SKU or the Fabric SKU. Basically, there's a version of Knights Landing that has OmniPath support integrated into the CPU package. And that's what we want to put into this cluster in order to take full advantage of the OmniPath fabric that we have. And that provides that CPU twice the bandwidth of any other node and what it would otherwise have. So we're waiting for that. We do have a couple Knights Landing nodes just to start porting things and see how they work. And those are going pretty well right now. So this is a very brief architectural diagram of how Summit works. Let's see where I am. This is, okay, so we have a number of compute racks. We have about 6.5 racks worth of compute. Each rack has about 60 nodes of the general compute and then some GPU in most racks. Those nodes are hooked into the OmniPath fabric in groups of 32 nodes. So between sets or islands of 32 nodes, you have completely non-blocking 100 gigabit per second networking with very low latency. I think there's a slide later about it's like 1.2 microseconds between nodes. Those top of rack switches that connect groups of 32 nodes are then aggregated into a core plane on our network that provides 2-to-1 blocking interconnectivity between those sets. So within a group of 32, you have fully non-blocking 100 gigabit networking. But then if you have a job that's larger than that, you can expect blocking up to 2-to-1. And then the GPFS scratch storage also hangs directly off of this network, giving the compute nodes, not only 100 gigabit network access to them, but also very low latency access to GPUs as native clients. One cool feature of this network, so the analog to this in the Janus computer is our InfiniBand fabric, which was fully non-blocking, but wasn't very well utilized at that scale. The feature that we have here is that we have a pair of what we're calling fabric gateway nodes that bridge this high-performance interconnect into the rest of the campus science network. So the upshot here is that data transfer and cache storage will be simpler and than it is on Janus. On Janus, this is like a weird back channel into the storage, and it's just very different. Now, not only do you have access to Scratch elsewhere on campus, but you also have access to Loam Project and other NFS directories through the high-performance interconnect, which today goes through gigabit Ethernet. Yeah,
is that what it seems like putting it in Globus?
But Globus is, yeah, so the question is that the same as bringing it through Globus? So if you are bringing data from off-site or from some non-research computing infrastructure, you will still use Globus to do that. But this is more like if you're on Blanca or another RC compute system, the path by which the data will take to just do the copy from one directory to another, which looks like two places on the same node, but is like 3 different data centers away, that will take a much more direct high-performance path. Day-to-day, what this will probably affect is just your NFS performance will be better. Things in your home directory, things in your projects directory, access to the PETA library from Summit will be better than it is today on Janus. Today on Janus, that's all going through a commodity 1 gigabit network link. Here, it will go through the connection to this here is 100 gigabit to each of these, and then the connection out is 20 gigabit out. So really, you have 40 gigabit of bandwidth going in and out to the science network, which is still better than the 1 gigabits aggregated up to a single 10 that we have today. So these are just some photos that Pete took of Summit as it was being installed. This is a fairly typical compute rack. This is the Dell C6320 chassis, which is a successor to what we were using in Janus. Here on the front, you can't really even see node boundaries. This is a 2U chassis, but around the back, and we have a graphic of this later, this is 4 nodes that are stacked this way, right, in quadrants. And then here, you have the OmniPath networking switches that aggregate all of, so we have switches in the top here also, but the compute nodes will aggregate into these, and then those go to another rack that does aggregation for the whole cluster. Then each of these compute racks, most of them anyway, all but 2, have 2 GPU nodes in the bottom and then a high memory node. And we'll give more specifics on the capabilities of each of those different types of nodes in a moment. Currently now. So a general compute node, we have 380 of them. Each one is equipped with 24 Intel Haswell Xeon processors. These are 5th generation processors. Each one has 128 gigabytes of RAM, so 5 gig per core, and a local SSD that we're using for the operating system is Scratch. So something that isn't mentioned in the presentation, but it is notable, I think, to people in this room. If you're aware, Janus uses stateless provisioning. They don't have, excuse me, the Janus compute nodes don't have hard drives or SSDs or any kind of local storage. And that has its benefits, but a downside that our users have experienced is that if you want new software installed that would come from the operating system, you usually have to wait for some kind of downtime for us to install that so that we can reprovision the cluster with a new image. That will no longer be the case. If you have a simple package that needs to go onto the cluster, we will just install it like you would on any other computer. And that's equipped by or enabled by having local storage on each node. We've measured performance on these. We're seeing about 76 gigaflops on each node, 290 aggregate.
How much SSD storage is on there? You said it can be used for scratch-based?
Yeah. So anything that is, so we have LVM on it, and so anything that isn't being used for the OS will be made available in like /scratch/local. I honestly don't remember how big they are. You can find out. They're not crazy big or anything. They're mostly there for the OS, but anything that's left over, we're definitely going to make it. So, okay. So in addition to the predominantly Haswell-based infrastructure, we have 10 of these general purpose GPU nodes. They're effectively identical, like they're a different chassis design, but the internals are basically identical to what's in the general Haswell compute nodes, with the exception of the fact that each one is equipped with 2 NVIDIA K80 GPUs. If you're familiar with the K80 architecture, each of those GPU accelerators is itself 2 GPUs. There's, in the program, you actually see 4 GPUs in the design. We're kind of expecting to break these up so that you can run up to 2 jobs per node, so that you can share these and have maybe a job per GPU if you're not ready to do 4 GPUs per node. But you know, that's also available to you. You have a question? All right, we have 5 of these high memory nodes, and these things are kind of a crazy thing that just got added to over time until we ended up with 2 terabytes of memory per node. They started out at 1 and just kind of accreted more memory over time. They also have 12 drive local RAID per node that will be local scratch for the node. And the thinking here is the types of work that require these kinds of nodes that really need 2 terabytes of memory on a single node are the kinds of jobs that not only don't parallelize across nodes very well, but also don't checkpoint very well because you've got 2 terabytes of memory to deal with. So we're providing these local RAID arrays so that you can load your data to the node, and it will make the jobs on that node less fragile. So like a reason we don't want long jobs is because the bigger your job is and the longer it is, the more fragile it is. If something goes wrong on the 6th day of your 7-day job, then you lose 6 days of runtime, right? But if you stage all of your data to the node, then maybe something goes wrong on the network, maybe something goes wrong on the storage, like the shared storage, but it's less likely to go wrong on the local storage on this node. So these are here to support long-running, maybe week or even 2-week-long, eventually, jobs. We'd really like to minimize that, but if you absolutely need it, and we expect some of our biotech type people that want to use this kind of a node, it's available. Oh, and then these are, in order to support that much memory, these are actually 4-socket boxes, which is why they have twice as many cores as everything else. That's really just because you need that many cores in order to run that much memory. Like there's not enough memory channels otherwise. Without really, really dense DIMMs, these are already pretty dense DIMMs. So in the future, we will have 20 of these Xeon Phi Knights Landing nodes. If you've used Xeon Phi Knights Corner, which was the previous architecture, the Xeon Phi is a PCIe add-in card that you kind of offload work to. It's no longer the case with the current generation of Knights Landing. They are a CPU that goes into a CPU socket. You log into it and you are running on Phi. So the goal is that these will be easier to program for. If you programmed on Phi before, you had to handle what memory was local and what memory was on the Phi, what was running on the Phi, what wasn't. These are servers that run Red Hat. There's nothing more to it. They're individually, each core is pretty slow. They're like, I think the test nodes that we have right now are like 1.2 gigahertz. But there's 64 cores per node. And if your code vectorizes really well, if it parallelizes really well, it will go really fast. Again, we're expecting these to be available early next year, but really it's just as soon as the SKU even exists. Oh yeah, this is what we're expecting. We're expecting about 2.5 teraflops a node, and then yeah, there's 20 of them. So this is the back of one of those C620 that I talked about before. Run just a bunch of hard drive bays, and we have one SSD. But on the back, you see the design a little bit more clearly. Each one of these sections is a node. We can pull them out, service them individually. The only thing they share between them is power. So you have 2 power supplies over here, redundant, up to certain workloads. If you're running like a full 4-node HPL on there, then maybe losing a power supply, you'll lose the chassis. But in general, we should be able to service these pretty well without having to take too many downtime. So we talked a little bit about the OmniPath before already. It is the next networking interconnect product thing. Take over the world and change everything. It is basically identical to InfiniBand in how you use it, except for that there are new lower level protocols. ID verbs or RDMA code today runs on OmniPath. In fact, all of the sysadmin tools still call it InfiniBand. But it does have new features under the hood that will hopefully be largely taken advantage of by your MPI implementation or your compiler. It's just going to automatically recompile that kind of thing, and take some specifics into consideration as you design your algorithm. And as I mentioned before, our infrastructure here, which isn't an OmniPath thing, but is the way we built it, is that our OmniPath interconnect will carry the NFS traffic from Peta Library and our core storage directories and things like that. So you should see better performance in there as well. Okay. Low latency, 1.5 microseconds. We already talked about this. 32 nodes per switch will be non-blocking. Do more blocking aside of that. All right, Scratch. This is done. Let's do this. Okay. Well, petabyte. Actually, it's creeping up again a little bit more than a petabyte of Scratch storage in GPFS. If you're on Janus today, this is true Scratch as Janus is Scratch is true Scratch. You'll have a directory per user. You can write data in there. It will be deleted automatically after some period, probably 90 or 180 days, something like that. We're using GPFS this time because it is better for small files than Lustre is. If you're not familiar with the GPFS architecture, it has a really cool way that it distributes metadata load across your entire cluster, including your clients. Whereas Lustre has a single HA metadata pair and only one of them is active at a time. And there's work being done to improve that in Lustre. Looking back to that exists, but this is kind of the best thing in this sector right now. We went with a DDN SFA 14K grid scaler appliance, which is basically 2 generations newer version of what we're using for Janus Scratch, just the GPFS version. And the biggest reason why we did that, aside from familiarity with the architecture, is that the DDN SFA 14K is meant to be able, and was the only product advertising direct connection onto the OmniPath fabric. This was another point of delay for us. Again, just not being available. It is not today directly connected to the OmniPath. The GPFS servers are, but the storage itself, servers are then connected to, are actually doing that communication over InfiniBand. And so we're hoping that eventually it will get that sorted out and we will reconfigure this so that it's a little bit more direct and less hoppy from OmniPath to server to InfiniBand to storage. But this is the way it is. And we're expecting greater than 2 gigabytes per second or, throughput onto this thing. And contrary to what you may have experienced with Janus in the past, and this is something we're seeing today, file creation rates and other metadata operations are just crazy. It's really, really fast. And that's largely not only because metadata distribution works better in GPFS, but because all of our metadata is on SSD in this infrastructure. Do you have a question?
So I guess, should there be any sort of files per directory limit on this, kind of like it was on Lustre?
So we will probably provide some guidance, but if you get yourself into that situation, it will not be anywhere near as bad as it is on Lustre. Or that's not even a Lustre thing as much as it is the current Scratch system. I haven't done this kind of, so sorry for the recording. The question was, will there be or should there be a directories per or a files per directory kind of limit? It's always a good idea to limit the number of files you have in a directory and to do some kind of fan out with a hash table or something. But at a previous site where we built a similar system that used PCIe flash, but still the whole point was all of the metadata was on SSDs. We filled in a single directory with like 1 million files and deleted it in like 5 minutes. So, something else that's cool about this that is a feature of modern GPFS that I don't think we mentioned in the notes anywhere is GPFS 4.1, we're using 4.1 something, added this feature for what they're calling large inodes. So an inode is a piece of metadata that stores your file name and other things. And normally that just stores metadata. You use it to find where your file is located on disk, what its name is, what its permissions are, that kind of thing. But GPFS has moved all of the inodes from something very tiny to 4K. So every inode is 4K, which is much bigger, relatively speaking, than the amount of data you actually need to store that metadata. And what they're using that slack space for is the first 3.7 kilobytes of your file. So if you have a tiny file, like a little bit of text, or if you're doing weird things like using files for communication between different processes, and you're just kind of creating some done files that write yes or no into a thing, that'll be entirely in the inode. So upshots of this are that file is completely on SSD. There's no disk read. It comes in your first I/O, so all you do is stat that file, and GPFS has all the data it needs, so there's less latency in getting it. And again, at a previous site, we've seen absolutely crazy differences in small file workloads on this kind of setup, and we expect that we'll have the same kind of a benefit here. Okay, as with Janus Scratch, the Summit Scratch will be available on the login nodes, data transfer nodes for Globus, and on the Summit compute nodes, all of them, the Haswell, the GPU, the HiMem, and the Night's Landing eventually. Will not be available directly from Janus, will not be available from Blocker or any other compute infrastructure that research computing provides. This is you should think of the Scratch storage for Summit not as a storage system, but as an aspect of compute, very much as the memory in the node is an aspect of the compute. Don't store your data here. Buy a PETA library. But we will, and we understand that there are data sets on Janus Scratch. We'll provide a mechanism for doing that. We're not sure exactly what that will look like yet. Like the simplest thing is just they'll both be on the TTMs and Globus, but we'll probably provide some way to sync stuff between them during a transition period. So we kind of touched on this a little bit. Summit has fewer nodes than Janus. Janus was 1,300 nodes. Summit is 400, which means since it's more than twice as fast, that performance is more dense. So it's more important that you use what you have well. If you get a node on Janus and you only use one core, you're wasting 11 cores, and each of those cores is slower. If you get one node here and you are using one core of it, you're not only wasting 24 or 23 of those cores, but more compute per core is being wasted. So we are going to support sub-node workloads here as a result, which is partially just we have to, because otherwise fewer and fewer people can take advantage of a whole node, right? But also Slurm has evolved to the point where we can do that more easily and better. So when you get a job on Summit compute node, you'll be in what's called a C group that will confine you to the amount of memory you've requested and the course you've requested, that kind of thing, which will mean that if you're sharing it with someone else, each person will be kind of confined into a logical part of the node, and you shouldn't really interfere with each other, except for the network bandwidth. But there's nothing you can do about that. We're also sharing Summit with not only CU researchers, but CSU, because they are part of the funding for it, and RMAC as a kind of selling point to NSF when we were applying for the grant. And then a portion of the Night's Landing stuff will be available to exceed also.
Could you say what RMAC is?
Yeah, RMAC is a Rocky Mountain Advanced Computing Consortium, which CU is a member and leader in. We do a conference once a year. You should go to it. It's awesome. And yeah, I don't know. It's a bunch of schools in the region. The kind of goal here is that Summit will be a regional computer, not just a CU computer. And if you're at an institution in the region who doesn't have HPC available, we want you to be able to use Summit.
Is that the one in August every summer, or is that
Yes.
conference?
I think it's the third week of August this year in the C building.
Next summer it will be on our campus. It was not.
Yeah,
It was at
in the
CSU this year, right?
Right, it was
Yeah.
at CSU this
Past
past year.
year, back here.
No, in the C building.
No fires this time.
Yeah, that's right. We don't have fire drills at our army.
That wasn't a drill. They had a literal fire.
Yeah.
And then we almost blew up a lightning storm. So.
So Pete wants to claim that you'll get a Nobel Prize if you optimize your code for something correctly. And you may if you can use that Knight's Landing process. Okay. So if you take a Janus code and run it on Summit, it may run, but it will not run well. So the first thing you should do is recompile. We're providing a new module stack with new updated compilers that are aware of the architectures that we're compiling on. Big thing with the Haswell stuff is AVX2, which is this SIMD, single instruction multiple data instruction set. Hey, cool, it's on the slide. So the goal here is that things that are just kind of a dumb loop in your code that does the same thing to a bunch of memory, your compiler knows how to send that to the CPU in a way that takes advantage of the AVX2 instruction set. And that is something that will not be in your binary if you compiled it for Janus. So you'll gain that kind of thing. There are other, oh yeah, and again, because we're more cores, 24 cores in the simplest node we have, 48 on HIMM and 64 on the Knight's Landing, you need to be expecting to be able to either thread or run multiple MPI ranks on a node in order to really take advantage of that. There's more. So these are some hints on how to enable vectorization. I don't know anything about this. I don't do any HPC programming. But largely it's about not having decision points inside of your loop. Hopefully this makes sense to you.
Jonathan, there's a chat question that I missed from 20 minutes ago.
Yeah.
From Tim at Wyoming. What are the recessed racks between the compute racks? So we're looking at a picture 20 minutes ago, and Tim sent that.
I don't think we had a picture of that up. He just saw it in the photo. So in the Janus data center, which is also the Summit data center, we have a kind of two-pod enclosed hot aisle design. So there's 2 rows of compute and other stuff, and then there's a roof and doors. And there's 2 sets of that. And in between most, if not all, of the compute racks, we have air handling units for cooling. And so that allows us to do all of the cooling in this data center. The high performance computing facility, or HPCF, is air cooled in the room, and then the air is cooled through evaporative cooling that is taken out of the room through water. Are you asking a question, Shelley?
I am going to suggest that now might be a time to get up the Intel training that we have. Unless you think that would be better.
Now is a good time to bring it up. I don't know anything about it.
I can talk a little bit about it.
I would love for you, because that obviously that is this.
Right.
I actually went, as I was reading through this, in my mind said, and we will probably provide some training, but I don't know anything about it.
So in 2 weeks, on October 19th and
Is your mic going to pick that up?
Oh, it should pick it up.
Okay.
Yeah, it should pick it
Stay
up.
closer.
I'll stand in the front. Actually, I can show the schedule here. Sorry, Matt.
Yeah.
Jump in the middle
Please
of your,
do.
although that's not gonna.
Yeah, I would say don't put stuff
All
up,
right.
just talk about it.
We're having a training on the 19th and the 20th of October. At NCAR in the Foothills Lab. There's a link on our website. If you go to rc.colorado.edu and you click on our news feed on the side, you'll find Intel HPC training. And the purpose of this training, we're going to have people from Intel there to help you learn how to vectorize, how to work with the Xeon Phi processors, and produce magic, basically. And this is,
Get that Nobel Prize.
yes, and so this is our way of, if some of you guys are like, I don't know how to accomplish this, so utilize Summit effectively, that's what we'll do. And there's a whole list of things we'll be talking about, which if you go to that site, you'll find, but we'll be talking about architecture, vectorization, OpenMP and SIMD, debugging, Intel MPI, all kinds of fun stuff. There's a fee associated with it because we're going to feed you. So anyway, I just wanted to mention that while you were on the slide.
So something that also should be said is if the way you use Janus and expect to use Summit is to use an existing application to process some data you have, very possible you don't have to care about this at all. We'll provide a new build that is optimized to take advantage of the new hardware. This is really important if you are doing programming. Right? If you're just using the computer to process data, then you might not have to. Something I also forgot about is that we have these beautiful little trifold pamphlets. If you want to take some information away about Summit, I'll leave those there. Feel free to grab them.
I had a question or two from previous slides. So there's SSDs on all the nodes now.
Yes.
Is there still a hard memory limit like there was on a lot of, I guess, the Janus and Crestone nodes? Or
what do you mean?
well, I know that like for any of the nodes that they went over the memory before, then they couldn't write to a local drive.
I see. So it's actually just came up in a conversation with our storage guys. So the question for the recording is, it wasn't going to pick up, is it's basically what we have, not scratch, but we have a swap space on the SSD so that you can overrun memory on the node.
Okay.
Right now, we don't have any swap enabled. Honestly, I think that may have just been an oversight, but we have to have discussion on whether that's a good use of it. That said, when you run a job, you specify how much memory you need. And maybe that only matters if it's a sub-node job, like if you're not using all the resources on the node. But in general, say I need 12 cores and 16 gigabytes of memory to run. The thing that's going to limit you there isn't the capabilities of the box, but that Slurm will restrict you to the resources you ask for.
Yeah.
And so that's to permit node sharing, so that if someone else is allocated to other memory. So if we have swap, it doesn't mean that the memory limit goes away. It means that we may allow Slurm to oversubscribe the memory, right? So you will still have a hard limit.
Yeah.
It just may be more than the physical memory of the box.
5 gigabytes per node is like usually what I need, so it's right around that. So in the past, well, at least for Janus stuff, I could never take advantage of all the cores, but now it sounds like with the larger memory and with
that was explicitly something that we were trying to design for. We knew that the memory per core was a little bit low on Janus, so we were hoping that this might be more what people would expect.
And then I didn't quite get what you were saying, how the scratch space is different now than it was for Janus. You said that it's not available on non-Summit compute nodes.
Right.
Is that the different part, or
that's not different. That's the way it was before. It's more just clarifying, because we've had a couple of instances recently where people have been storing data on Scratch.
Oh, they don't realize it's Scratch.
We're just emphasizing that it's Scratch.
Okay.
It shouldn't be used for storage. It's not available other places because it is Scratch. Okay. But that's the same as Janus.
But it's still accessible from all the same nodes and things that it was before.
Yes.
Okay.
I think there might be one node weirdly somewhere that has access to Janus Scratch that shouldn't. But Summit
Scratch. You can read only, I guess, on some other compute, yes?
Maybe.
It's that could be a TBD, but yeah, I know there are times we talked about having it read only from, because it's closely coupled. Currently, the Janus Scratch is attached directly to the Janus low latency network.
Well, the Summit Scratch is attached directly to the Summit network too.
Which means that it's not necessarily the right Scratch if you're using IMM or using Crestone.
Yeah.
So in those cases, you can make a case for loading it or mounting read only.
Yeah.
My question was more about the Summit Scratch, not about the older Janus Scratch.
Yeah.
I think that's what you were referring
Well,
to.
what I'm saying is that paradigm might translate to Summit, or we may say it does and then change our minds or something. You know what I mean? We need to find the right user.
Right now, the absolute plan is exactly like it is on Janus, or as we conceptualize it on Janus.
Thank you for clarifying.
That it is only mounted on Janus, only mounted on Summit, with the exception being the same exceptions today. It's on the login node, it's on the TT nodes.
Great, thanks.
Yeah, I have a question. So is there a command to actually see how much memory you're using while you're, because I know I would paralyze stuff and then I would go over my limit. So I guess I don't know, like, besides trial and error.
Yeah, memory use in Linux is weird and finicky because it does all of this like deduplication of if you load the same DLL or the same shared object from multiple places, and that gets condensed down, so it's hard to tell because the apparent size of your application is actually bigger than the memory it's using. Slurm tracks it because it has to in order to find you to, but I think you can ask Slurm with Slurm control.
You can ask Slurm, but its sampling rate is fairly low.
Yeah.
And it'll often, I was just looking at the job yesterday, it said it used 60% of its memory, but then you look at your job output, it ran out of memory. And Slurm just hadn't sampled during the steep part of the curve.
Gotcha.
So it's also possible that you can ask the C group how much of the memory in the C group you're using, but I don't know how to do that. But I will take a note to find out, because that is something that we will want to be able to tell people how to do.
Yeah, that would be helpful.
We also want to provide that kind of data, if not real time, just after the fact to users. We don't have that right now, but that is something that post Summit being available, we want to focus on providing more of that kind of metadata so that when your job
dies,
you can get a graph to see the memory go like this.
That'd be awesome.
Yes, that would be awesome.
But we don't have it today. It is absolutely a goal and an intended plan.
It's hard on 1 or 2 nodes, but when you've got 100 nodes and you want a high sampling rate, it's pretty challenging. It's really trivial to script something that runs.
We're still getting some of the meeting.
Oh, what are they talking about? So some other miscellaneous interesting things about Summit is that it's running right at 7, which is both a good idea.
We'll see. They're still going on some, so.
We will be upgrading the line nodes into their RC infrastructure to run at 7 as a result also, but that'll probably come later. We are changing a little bit about the way Slurm works, largely just to provide more flexibility around the different types of Summit nodes. And there are other little things that will be better and easier now too, like the ability to share a node on a Janus, or not Janus, on a Summit node, and you won't have to load Slurm out of the module system also. We'll be providing allocations as before, but rather than what they were before, which is kind of a strict bank account core hour thing, what we're actually intending to do right now is to translate your service unit or core hour requirements into a fair share allocation. So you won't ever run out of time. What happens is the more you use it, the less priority you have for future jobs. It's kind of dynamically handled by the schedule. And then the cost associated with each job is different depending on where you're running it. So like a high mem node might cost more than a general compute. And a GPU node definitely costs more than a GPU, or than a general compute node. So if you're running a oh yes.
So how do you write a proposal for time if you're not applying for actual time?
So we absolutely expect people to predict their core hour requirement, and then we will use that as a like we compare that to how many core hours the machine actually has, and use that to give you a proportional share of the fair share. So you don't have to worry about fair share and what it means, except for when the job is running. When you write your proposal, do it every way you always have. I need this many core hours. And rather than cutting you off when you use it up, you just go relatively lower priority compared to other people's jobs.
What's the advantage of that system instead of just the bank?
So the biggest thing is that it's really how Slurm expects to work. And the fact that we've been doing SU allocations in Slurm has been kind of a hack and a kludge that doesn't work very well. The benefit to you guys is that you never will get into that situation where you run out of time and can't run. If you use up your allocation, if you ask for 50,000 core hours and you've used 50,000 core hours, you don't now have, like, if the machine is sitting empty, you can still run. You don't have to wait until we approve another allocation. If you need more priority, you can still do that and we can give you more priority. But if you're still running, it doesn't matter. You can just keep on running.
So I guess if I apply for a certain number of hours, is it expected that I use that over a certain amount of time? Like,
It is of course better for
the share
everyone
amount
if
that
you
I
do.
get.
Because if you apply for it and then after 12 months expect to get 50,000 core hours all at the end, you're going to be competing with everyone else who did the exact same thing.
It's gonna favor more even use, less spiky usage of, in other words, if you don't use it for 2 months, you have essentially lost that ability to grab that advanced priority. This is likely to be necessary with the likelihood that Summit's gonna be fairly busy, and the spikiness is fairly problematic for, making an efficient use of the machine.
Something I didn't point out though is that while using the system decreases your future priority, not using it increases it. So over time, the goal is that everyone's proportional use of the system is fair, right? That you have access to a proportional amount relative to other people that is moderated by priority rather than hard limits on how much you're allowed to run.
So I guess if I apply for a big amount of time and I get it, it's going to be hard to complete that in say like 2 months, but it'll be easy because if I'm using a lot of it, my priority will go down, right? So I'm going to spread it out over.
But it'll go down less than someone who had a smaller allocation and also used the same amount of time, right?
Yeah, we may need to think about, having a smaller time slice rather than say a year between the times we evaluate your slice of the system via this priority for campaigns. We may actually have the time to do that because this methodology may allow us to not have to do much for people who just need to use MATLAB once every 2 months or something. Whereas in the current paradigm, that means you have to have a full-blown project allocation. And then you come back after a year and over, it's expired, and this happens a lot. So theoretically, this allows us to service situations like this and bump priority for campaigns that we're aware of.
We could always, another feature that's in Slurm that we don't use for users that often right now is reservations. And if we knew that there was some we're going to be doing a lot of science for 2 months, and it's going to be awesome, we could always do something more, special case for a special project program.
That's certainly possible. We have done it in the past, particularly for people who had slightly outsized needs in terms of wall time or node count or something like that. But we may be able to be more flexible.
Yeah. And then just a little bit more kind of into the weeds detail on how that works. The half-life, so the priority hit that you take when you use the system has a half-life of 2 weeks. So it kind of falls off relatively quickly. And this is new to us too, and we'll be kind of twiddling with these thresholds over time if there are problems. But we do think overall, this infrastructure is a better mechanism for providing service to people.
Yeah, particularly since we've had people try to sort of hoard time and get 2 million hours and they never use it, and and it's like, how's that going to work?
You can't save a core hour.
Yeah.
If you don't use it, it's wasted. Right?
Yeah, it's like tickets to a play that's going to run for a month. Next month, we don't have anything.
Is Janice going to be officially offline?
Right. So the question is, when is Janice offline? And we want to know that as well. So the original answer was as soon as feasibly possible when Summit is up and ready and people can actually use it. I think that has been pushed out a little bit because there's a class running now that is dependent on it, so it'll probably run at least until that class is over.
When is that?
I'm sure it's a semester. It's more just that there will be a transition period. And it's not going to be, okay, Summit is available, you better move on to it because Janice is gone next week. It's not going to be something like that. That said, Janice is really old and is falling over. And just yesterday, we had this maintenance downtime. And when we brought it back up, we lost the top of rack switch in one of the racks. So we lost 32 nodes, right? The nodes run, but we have no support, no way to get replacements. So it's dying, right? So we need to get off of it as quickly as possible. Oh yeah, we never even talked about this slide. So this is the way you will submit the jobs into Summit. If you do Janice today, you might submit to Janus Long or that kind of thing. You always submit to a QoS, which we've kind of been abusing as though it's a queue if you're familiar with PBS-style queuing systems. But Slurm doesn't really work that way, just kind of pretending it does. Slurm divides resources up into partitions, which we're mapping to the different types of Summit compute nodes. So we have a Haswell, a GPU, a memory, and a KML partition. So you submit to that partition in Summit, and then also provide a QoS, and there'll be a default one, which is just normal or default or something like that. But then if you want a long job that's more than the 24-hour maximal time you get on a normal job, then you submit a long QoS job to the SHAS partition, right? So in the past, we kind of did the matrix multiply for you and presented a list of possible QoSs that populated both of these values. Now instead, you have to specify one more parameter, but it means you can submit any of these types of jobs to any of these locations, and you're not limited to the combinations that we provide or some big list of them.
Why is nice landing 0.1 for the scaling thing?
Because we want to encourage people to use them. So yes, in a pure processing capability standpoint, these should be much more expensive. But nobody uses them today because they haven't existed. So yeah, if you want to run on the Knights Landing and are willing to, we want to encourage that. And so we are making it cheap to run. And the question was, why is the Knights Landing 0.1 the scaling factor?
And that's your, like, kind of priority scaling factor?
Yeah. So our expectation is that you will say, I need this many core hours like this. And then if you run anything like this, if you run 6 core hours here, it will be 6 times of your relative allocation as the view. Yeah, so we talked about this a little bit already, but you will still need allocations, but there will be kind of a general or default or scavenger or some kind of allocation that anyone can have access to. It's really low priority compared to anyone that has written a proposal, but it means that you can get on and run with minimal effort. You can then also write a proposal and get a formal allocation that will be translated into a fair share allocation on the system. It will allow you to run. Important to note that if you have a Janus allocation today, you will not automatically get a Summit allocation. So whatever, you can easily get access to the default one, but if you need higher priority, you will need to do some very minimal work to tell us what you want to do and how much you need. There will be these 3 types of allocations: the general one that everyone can have, project one that you get as a result of the proposal, and then we will be providing an opportunity to buy into Summit as a condo resource. And people who do that will have a special condo allocation that gives them higher priority relative to the amount of compute that they've purchased. Apparently, how to apply is to wait for us to tell you later. And we've talked about fair share a lot already.
As far as applying goes, we're going to be expecting people to have jumped into CU General and done preliminary work. We're not interested in allocations that are proposals that are not based on actual work on Summit really at this point. Because I don't really think that what would you say?
I'd say that that's accurate. You and people know better than I will, but I don't know if maybe really a lot of experience on Janus might justify an allocation on Summit. No?
No, because we really want to see people using those SSDs and making organization. Because, well, my talking point is that if we take advantage of Summit's capability, we have more resources going forward. If we don't, we have less.
Yep.
So, and we can't afford to have less. So the allocation process is going to focus on how you did or couldn't take advantage of these advanced features in Summit. Therefore, you really need to have some data from preliminary work.
Yeah, and this is similar, if you've been running on Janus, to the startup allocation process that we had before, where we made it really easy to get a startup allocation, and then you would do some work, and then with the work you did in your startup allocation, you would say, okay, now I need a full allocation, and I know how much I need because I ran my application and it performed this well. The difference is, now that we aren't doing bank-style deduction type allocations, just run in that lower priority one and you'll be competing with people who already have allocations, but you can do all of the work that you can fit into it, right?
It may totally work for you. We are still going to expect you to have PI supervision after a shakedown period. We're going to expect you to do reporting. We're absolutely required to do reporting. So you're not going to be able to totally fly under the radar, but you may not have to do a full, if you're getting by in CU General, because you run a few things every couple of weeks, then you may have a lower paperwork load.
So we're also going to use a fair share system to divide up the resource between the different stakeholders. So proportionally based on funding, CU-Boulder is getting apparently a 67.5% share of the machine, CSU a 22.5%, and then we have 10% dedicated to RMAC. And so when you get your CU allocation, what you are getting is a portion of the portion of CU's allocation of the system. But again, this is all just priorities. It's not like you're limited to 80% of the machine or can't scale up to a large run, or that if you do, you will be in some way punished other than other people then who haven't done that yet will go first. So, as I alluded to before, we hope to and intend to provide the opportunity to buy nodes in Summit as a condo. And to be clear, this is not buying some ownership over an existing node that's installed. We want to purchase new nodes and install them for your benefit. So similar to the Blanca system today, we have a pre-negotiated price for these nodes. Apparently it's, about $8K for general compute. We're also requiring that this will increase the scratch storage and the network, or the networking we're providing, I think, but included in this purchase price is additional scratch to kind of scale that up at the same rate that the compute goes up. Because it would be a shame if we say doubled the compute but didn't double the scratch and suddenly we're all starting from scratch. Right, okay, I understand how this is being said here. So it's 8K for a general compute node, 18,000 apparently for a GPU node, but CU researchers will have access to the safety net subsidy as a CU.
So that 8840 is before the subsidy.
I think that's before the subsidy, and that's because this data is also applicable to CSU researchers who are also wanting to buy condo into it that won't have access to that subsidy from CU. Maybe CSU will provide something else. So we're hoping to do this in 2 phases. The first phase is kind of going on right now. We had hoped to have Summit into production before now, so the people who were interested could have experience running on it and see how well their code scales. But if you're interested, send us an email, and we'll, there's a limited amount of space that we can deploy up to. So let us know if you're interested.
So is that support included?
Yes.
I mean,
it's 5 year. It's supported as long as the rest of Summit is, which is a 5-year period that has not yet begun.
It's a pretty good deal. Not, of course, I'm biased, but it's a pretty good deal.
Yeah.
Perhaps a very good deal, actually, if you do the math. If you don't have.
Yeah, what do you say there are 24 nodes, right?
24 cores per node.
24 cores.
128 gigabytes per node. We provide the networking infrastructure to connect that to the rest of the cluster, and the storage infrastructure. It does include additional disks that go in as a result.
And your particular node never goes down. It's never like your node died. It's just whichever you're going to keep that priority bump that you get from having bought the node.
Yes, it won't be quite like Blanca Condo where you buy nodes and then you run on those nodes and can sometimes burst out. It will be you buy a node and now you will always have one node's worth of crazy priority, right? So you don't have the same fragility of if you bought a node and put it in a rack somewhere. So that's all of the material I have for today. I, of course, can still answer any questions if you have them, but otherwise, feel free to email. Oh, yes.
Here's a question.
What? Oh, yeah. Something else we can do if you're interested real quick before is if you want to use the Duo 2-factor system, we can do ID checks for that. today and send you invites and things like that.
Yeah, and if we have the room, I can answer questions about our as well.
Have you done it already?
But yes, there was.
Yeah, so if you're, like, I have a
They just
thing
have.
where I'm like running Python script and it calls it a sub process, and it opens up like another like Unix.
It's nice.
Terminal window. How does it actually like work with like batch jobs?
So you're calling subprocess and it actually brings up the graphical.
Well,
when you do that.
well, I tuned the graphical thing off, so it opened one up, but I guess it brings up. I guess I don't know how that works with the batch.
So subprocess is just forking and execing another process.
Yeah.
So that will happen in your batch job. It will just open another thing, and if it's not interactive, it will spawn and can run on two different processes.